Okay, friends, so I wanted to show you what it means to be an electrolytic cell. And some of you may have seen me do this for the Gen Chem class, um, so, but it works for you guys here on a second level. And it's a real pity that we're having to do this remote. So what I've done is I've taken a little condiment cup and put two screws through it. And I've got a glass here, and in it I've dissolved, it's just water with baking soda, and it works better if it's distilled water, but this will still work. And so I'm just going to fill up this little cup. I got a little bit of a mess on my table, but that's okay. And there we go. Good. Be back in a sec. Let me mop that up. So I am probably going to make more of a mess while I'm here. And what I'm going to do now is the baking soda is just in there because this isn't vinegar where it fizzes. The baking soda is just in there to conduct electricity. So it's the water that's doing everything. And here I've got a cheap 9-volt battery. Nothing special about that. And I'm going to stick, you're going to see here in a sec. Try to get this to work. I don't know if you can see that, but that is totally fizzing now. And try to get just a little bit closer for you. And so this is what happens when you have an electrolytic cell. That in order to make the chemical reaction happen is you need electricity in order to make the reaction go. This reaction doesn't want to happen on its own. And so here you've got bubbles coming up at both metal screws. And that means that you're producing two gases out of water, H2O. So in a second, I'm going to show you guys the chemical equation and what it means to force this to actually happen. Really simple idea, but it really gets the point across. And it'll help you review how to balance a redox reaction, but you actually get to see what's going on here. And I don't know if you can hear, but one of these sides is bubbling way faster than the other one. So really cool, really simple little example, but gets the point home of, oh, that I had all of that stuff in here when I poured it in the cup, nothing was happening. It wasn't going to happen. But once you apply the current to it and you hit it with a 9-volt battery, you took a thermodynamically unfavorable process and made it favorable, and now it happens. All right. Pretty simple, pretty cool. We'll finish this up in a sec.